question like this, proving trigonometric identities, where you have an expression on the left hand side and the right hand side. Normally students tend to start off with the left hand side and manipulate it, try to make it look like the right hand side. But keep in mind that we can also go the other way around. We can, for example, we can go from right hand side and manipulate it, try to make it look exactly the same as left hand side. So the key idea is you can go from one side to the other and try to look for one that is more complicated. So for example, in this question here, the left hand side look more complicated. So I will start up with the left hand side and try to manipulate it to make it look like the right hand side. Okay, but keep in mind you can go the other way around. Okay, so let's go through this example. Now, so start off with the left hand side. In your working out, make sure you clearly state which sides you're starting with. Okay, now we talked about this in the previous video. We refer to work with sine and cosine only. Okay, so if we see ratios such as cosec, sec and tan, then we will change it into expression that has only sine or cosine. Okay, so for example, left hand side here, cosec. With this cosec, I'm gonna change it to 1 over sine theta. With sec, I'm gonna change it to 1 over cos, and tan, it's gonna be sine over cos. So rearrange that, not rearrange. So let's change this and make it into the expression that we want. So we want sine and cos only. Okay, so this is what I did. Alright, so now we have an additional fraction on the top in the numerator and another additional fraction at the bottom at the denominator. So if you can't work with such expression like this, I would recommend you separate them out. So what I would do, I would write, remember fraction means dividing. So this is the numerator. Over it means divide. So I'm gonna rewrite it as numerator divide by the denominator. Okay. Then we work with each bracket separately first. So here we have an addition of fraction, 1 over sine plus 1 over cos. So we need the common denominator. So common denominator in this case is sine theta cos theta. Okay, and we cross multiply the top to have cos theta plus sine theta. And with this addition here, we will do the same. Okay, we need the common denominator in this case, which is cos, and cross multiply to have cos theta plus sine theta. Okay, now you have a fraction, divide by a fraction, so we know that we have to multiply by reciprocal. So keep the first fraction the same, and we're gonna change this to multiply of the reciprocal of the second fraction. So it's gonna be multiply and flip the second fraction around. Okay, and now it's much simpler to start cancelling out. So here I have an expression for cos theta plus sine theta, which is exactly the same as this. So I'm gonna cross these out, and here I have cos theta here, I have cos theta here as well, so I can cross them out. Okay, so now we can simplify these now. So whatever we have left now will be okay, on the top we have nothing, so it's 1 left, and at the bottom we only have sine theta left. Alright, now normally this is already simple enough if we have to simplify the expression like the one in the left hand side, but we're trying to prove here, so we're trying to get into here to the right hand side, so we have to make it look like the right hand side. And obviously 1 over sine, the reciprocal ratio, is cosec theta. Okay, and that's right hand side, so clearly to say that it is the right hand side, and we've completed our proof. Alright, so again, keep in mind you will look for the side that are more complicated. Okay, so in this case we have left hand side is more complicated, that's why we start off with left hand side, but keep in mind we can also go from right hand side and try to prove that it looks like the left hand side. Okay, now I have the second dot point here. Sometimes it is quite useful that you show that both left hand side and right hand side is equal to the third expression. Okay, sometimes it is useful to do that instead of going from one side to the other. So I'm going to show you how to do that next. So let's delete this so we have some space. Okay, so here for this example, I have this tan theta plus cos theta, and we try to prove that it's equal to sec theta multiplied by cos sec theta. So left hand side and right hand side look equivalently complicated, so it doesn't matter which you go from which side to which side now, but I'm going to show you the second method, that is to make both of them look like are equal to the third expression. Okay, so I'm going to start off with the left hand side. Okay, left hand side. So again, we're gonna change each of this ratio into something that related to sine and cos only. So I'm gonna change left hand side. I'm gonna change tan to sine over cos, and cotan to cos over sine. Okay, some people might argue that tan and cotans are reciprocal of each other, why don't we use that, and so on. But keep in mind there's different way to do a question like this, but I prefer to stick to my method that I change to cos and sine, and most of the time it is quite simple. I mean, it's simpler to do. Okay, so that's what I did with the left hand side, change to cos and sine. Now we have addition of fractions, so we need common denominator. So common denominator in this case is sine theta cos theta, and when you multiply, do the cross multiplication, you got sine square plus cos square. Okay, now if it's square or square with number 1, then we should think about Pythagorean's identity. So we have this one here, the very basic, or the first Pythagorean identity that we learn. So sine square plus cos square, again it's Pythagorean identity, the first one that we learn, and it is equal to 1. Okay, so this become 1 over the denominator. Now sometimes, let's say I get up to here and I try to make it equal to the right hand side, but I get stuck here. I don't know where to go. So I can actually stop right here for now and see if I can make the right hand side equal to this expression as well. Okay, so let's do that. So let's start with the right hand side. So right hand side is sec theta multiply cosec theta. So I'm going to change sec to 1 over cos, and cosec is 1 over sine. Okay, so we have this now. Now multiply fraction, so you just multiply the top together and multiply the bottom together. So we have this expression. Okay, and have a look. This one, let me highlight it properly. So this right hand side is equal to this expression. Left hand side we also prove that it's equal to that expression. So that's what I'm saying. We're trying to show. Now we can make conclusion that they equal to each other. Okay, so make sure in your working out you have to say left hand side now equal to the right hand side, and you can say that's equal to this expression here, and we complete our proof. Alright, so keep in mind you can go from one side to the other, starting with the more complicated looking one, or you can make both left hand side and right hand side equal to the third expression like what we did over here.